Hello everyone. Now today we're going to discuss about Stokes theorem. Okay. Now look at the statement of Stokes theorem. Next problem on the Stokes theorem. Okay. Now if S is a open surface bounded by the closed curve C and a bar be any continuous differentiable vector point function, then integral over C f into dr equal to integral over S curl f into n bar ds, where n bar is a unit outward normal for the surface. Okay. Now this relation we're going to make it equal. Okay. Now look at the first problem. Verify Stokes theorem for a bar equal to x square minus y square I plus 2xyj in the rectangular region x equal to 0, y equal to 0, x equal to a and y equal to b. Okay. Now first draw these lines now which make a rectangular. X equals 0, nothing but y-axis, y equals 0, x-axis, x equal to a parallel to y-axis, y equal to b parallel to x-axis. Okay, now this shape like a rectangle. Now we're going to verify Stokes theorem on this f. Now by Stokes theorem, integral over c f into dr equal to double integral over s curl f dot n ds. Okay. First consider the LHS. Now next find the value for RHS. The both we need to prove both are same. Okay. Now LHS over a C or a curve integral over a C. Now C is a rectangular here. That rectangular divided into 4 lines. Now to do the integration over that vector, which is same as over the integration of 4 lines. Okay. Now integral over CF into dr can be divided into integral over OA and integral over AB and integral over BC and integral over C. Okay. Now these integration we need to find one by one. Add it all these 4 integration you can get for LHS. Okay. First find the LHS. Now first along OA. For OA line is lie on x-axis. Simply x-axis equation is y equal to 0. Along OA, y equals 0, dy is 0. Now x varies from 0 to a. 0 to the point we have a. Y is 0. Right? Now apply the change integral over OA f into dr. F dot dr. Dr is a deviation position dxi plus dyj. Do the dot product x square minus y square into dx plus 2xy dy. Now we say f into dr. Now apply the change here. Now y equals 0, dy 0. Now dy 0, this term total is 0. Here y is 0. Okay. Remaining x square dx. Now this you have to integrate with respect to x cube by 3, limits of 0 to a. Now apply the limit a cube by 3, lower limit is 0 here. Simply a cube by 3. Now along AB now. Along AB, now along AB the line equation is x equal to a, right? Now dx is 0, but there is no deviation. Now y varies from 0 to b. 0 to b. Now integral over AB f into dr equal to integral y equals 0 to b x square minus y square dx plus 2xy dy. Now apply the change x equal to a. X equal to a square minus y square into dx is 0 plus 2 x equal to a y 2ay into dy. Now this term total is 0. We have this term only. 2a is a constant. Y integration is y square by 2. Now limits are y equals 0 to b. Apply the limits. A into 2 to cancel. A into b square minus lower limit is 0. No need to write it. A b square. Next along BC. For along BC y coordinate is simply b, right? The line we have y equal to b, right? BC is a line y equal to b, dy 0. Now x varies from a to 0. Okay, now all should be in same sense. I take for anti-clockwise direction, that's why in the same sense we need to use it. Now here BC, the anti-clockwise sense, that is the reason the x varies from a to 0, not 0 to a to 0. The x varies from a to 0. Now apply the change, integral over BC f into dr equal to x equal to a to 0 x square minus y square dx plus 2xy dy. Now dy is 0 here, now this term 0. Now y equal b substitute here. Now this you have to integrate with respect to x. X square integration x cube by 3 minus b square integration with respect to x b square x. Now limits a to 0. Apply the limits, upper limit apply it. 0 cube is 0, b square into 0 is 0. Upper limit is 0 minus lower limit a cube by 3 minus b square a. Now multiply the minus into this minus is plus, ab square first, minus into plus is minus a cube by 3. Now next along CO is a y-axis, simply x equals 0. Now y varies from b to 0. Y varies from here b to here 0. Now here along CO, x equals 0 and dx equals 0, y varies from b to 0. Integral CO f into dr, y equal b to 0, x square minus y square dx plus 2xy dy. Dx 0, this term 0. Now here x value 0, here also 0. 0 dy, integrand is 0, simply the value is 0. Now all these four integral put it in a LHS side of the Stokes theorem. Integral over CF into dr equal to integral over OA is a cube by 3 plus integral over AB is AB square, integral over BC is AB square minus a cube by 3, integral over CO is 0. Okay, now here plus quantity of a cube by 3, here negative of a cube by 3 will cancel, remaining 2ab square. Now this is a LHS of the Stokes theorem, integral over C f into dr. Now let's look at the RHS. Now the RHS we have double integral over s curl f into n dot ds. Now before finding this integration we need curl f. Now find the curl f. Curl f equal to ijk dou by dou x dou by dou y dou by dou z. Now first I component for a of x square minus y square, j is 2xy, z 0, k value 0. Now find the determinant I into now 0 of dou y by dou is 0 minus dou by dou z of 2xy. There is no z, right? Simply derivative is 0. Now minus j into dou by dou x of 0 is 0 minus dou by dou z of x square minus y square is 0 plus k into dou by dou x 2xy derivative with respect to x is 2y, x derivative 1, 2y minus with respect to y derivative, x derivative 0 minus y square derivative with respect to y is minus 2y, no minus 2y. Now here minus into minus plus 2y plus 2y, 4y k, remaining I and j components are 0. Now this is a curl f. Next n bar we need to find it. Now our given rectangular region on xy plane we have. Now this is on xy plane. Now simply outward normal is z axis, right? Outward normal is z, that is a k. Okay, now n bar is k. Now for this surface integration we need to pick up the limits. Now to cover this region we need to pick up the limits. Now y varies from 0 to b, now x varies from 0 to a, up to a, right? Now 0 to b, 0 to a. There is no curve, all are lines, right? Simply we have constant limits. Now next integral over s curl f and dot ds, y is 0 to b and x is 0 to a. Now curl f is 4yk dot n is k into ds. ds nothing but the surface we are on xy plane, the deviation also we have along x comma y only, that's why dx dy. Now k dot k is 1 dx dy. First integrate with respect to x, y or x, your wish. First I integrate with respect to x. Here 1 is an integrand, that integration is x, 0 to a, next dy. Here upper limit minus lower limit is a. For a, that I write it outside, y. Now integration with respect to y is y square by 2. Apply the limits. Now 4a into b square by 2 minus lower limit 0. Now 2 1s are 2 2s are 2a b square. Now LHS we have 2ab square. RHS we have 2ab square. Now LHS equal to RHS. We verified Stoke's theorem for the given function f. Okay. Now next class I going to discuss some more problem on Stoke's theorem. Thank you.